Homework 21, we're going to start by finding the x and the y intercepts of our line given our equation. The reasons we might find the x and the y intercepts is we can use that to graph, and we're going to do that later on. But first they're just going to have you find the x and the y intercept. And we can find the x and the y intercept by plugging in some numbers and finding our points. But we have to pick out the correct numbers. For my x-intercept, the y value is always 0. For my y-intercept, the x value is always 0. So what happens when I do that? For my x-intercept, negative 6x plus 5 times 0 equals negative 15. Get my negative in there. Here, anything times 0 is going to be 0. It's basically just going to get rid of the y term from your equation. So negative 6x is going to equal negative 15. So here, all I'm going to end up doing is dividing by my negative 6 and simplifying. I have a negative over a negative, which is going to be positive. Both of those are divisible by 3, so 5 over 2. Now, right now, you're just going to put in 5 over 2 for your x-intercept. When you graph it, you're going to have to enter it in as an ordered pair. So for your x-intercept, the x value is 5/2. The y value happens to be 0. So as an ordered pair, my x-intercept would be 5/2 of 0. On here, on this part, you're just going to do the 5/2. For my y-intercept, I'm putting 0 in for the x. So negative 6 times 0 plus 5y equals negative 15. When I put 0 in for the x term is gone. So I'm going to take negative 15 and divide it by the 5. Y then equals negative 3. So my y-intercept is negative 3. Again, I'm just going to type it in like that. If you had to put it in as an ordered pair, remember that the y value is negative 3, so x is 0, y is negative 3. That's my ordered pair. Now, just a quick way to do this without putting your number in, or if you want to do it in your head. If I'm going to put 0 in for y, the y term is just going to be gone. I'm going to take my negative 15 divided by the coefficient of my x, so negative 15 divided by negative 6, because the y is gone. And then I simplify. Same thing for my y-intercept. For my y-intercept, the x was 0. So I got rid of the x term. If I just cover up the x term and solve this, I'm going to take the negative 15 divided by the 5. Negative 15 divided by 5 is negative 3. So you can write it out and substitute the number in. That way you understand what you're doing. But the quick way, for your x-intercept, cover up the y and then take negative 15 divided by negative 6. For my y-intercept, cover up the x. Negative 15 divided by 5. Number 2 then, doing the same thing, finding my x and my y-intercept. So I'm going to put 0 in for y to find my x-intercept, 0 in for x to find my y-intercept. So for my x-intercept, 5x minus 6 times 0 equals 10. This cancels out, so I'm just going to have 10 divided by my 5, which is 2. For my y-intercept, putting 0 in for my x term. So 5 times 0 minus 6y equals 10. That cancels out. I'm going to divide by my negative 6 and simplify. So negative 5 over 3. So 2 and negative 5/3. Number 3, same kind of thing here. I'm finding my x and my y-intercept. So for my x-intercept, y is 0. For my y-intercept, x is 0. So putting 0 in for my y, 7x plus 4 times 0 equals 10. Gets rid of my y term. 10 divided by 7, can't do much with, so 10/7 is going to be my x-intercept. For my y-intercept, I'm putting 0 in for x. 7 times 0 plus 4y equals 10. So again, it gets rid of the x term. 10 divided by 4, I can reduce that down. So 5 over 2. So for your x-intercept, y is 0, gets rid of the y term. My y-intercept, x is 0, gets rid of the x term, and then I just divide to solve. For 5 and 6 then, we are going to graph an equation by finding the x and the y-intercept and plotting our points. That's why on the previous ones I showed you what it was as an ordered pair. But basically I'm doing the exact same thing I did on 1, 2, and 3, just adding that I'm going to plot those points and solve. So for my x-intercept, the y is 0. So 3x plus 2 times 0 equals negative 6. We get rid of the y term, divide by our x coefficient. Negative 6 divided by 3 is negative 2. So my x-intercept is that nice whole number, negative 2. I can plot that one just by clicking on my negative 2 on my x-axis. For my y-intercept, putting the 0 in for x. So 3 times 0 plus 2y equals negative 6. Gets rid of my x term, so I'm going to divide by my 2. Negative 6 divided by 2 is negative 3. Again, that one came out to a nice whole number, so my y-intercept on my y-axis, I'm just going to mark where the negative 3 is. Once I have those 2 points, I'm going to use that line tool, click on my 2 points, and it's going to put the line connecting those 2 dots. So number 5, same kind of thing. I'm going to graph that by finding the x and the y-intercept. So for my x-intercept, y is 0. 2x minus 5 times 0 equals negative 5. Again, that gets rid of the y term. I'm going to divide by the 2, and I get negative 5 halves. This is one where you would have to let the computer plot the point because you don't know exactly where negative 5 halves is. So there's going to be a tool. It looks something sort of like this, and when you click on it, it says plot a point anywhere, and you have to enter it in the ordered pair. That's why I said you have to remember when you were making your table. In this case, if I were making my table, the x is negative 5 halves, the y was 0, we put 0 in for y, so negative 5 halves 0. That's going to be about at negative 2.5, so I'm just going to estimate where that is for now. But on Alex, you have to type it in and let the computer plot that point for you. So my y-intercept. Y-intercept, I'm putting 0 in for x. So 2 times 0 minus 5y equals negative 5. This one turns out nice because I'm just going to divide negative 5 by negative 5, and I get a positive 1. Now you could put the ordered pair in, 0, 1, and let the computer plot it, but it's a nice whole number. We know where y equals 1 is, so it's just as easy to put it in with the pencil tool. It's up to you which way you want to do it, but once you have your 2 dots, again, you click on your line tool, click on those 2 dots, and it will put the line in connecting those 2 dots. So on number 6, notice on number 6 we're not quite in standard form because the h is over on this side of my equation. So before I do my x and my y-intercept, I'm just going to make sure it's in standard form by moving my 8 to the other side. So I would have to add the 8, and I would have 3x plus 2y equals a positive 8 then. Now that it's in standard form, I can go ahead and find my x and my y-intercept. So for my x-intercept, y is 0. 3x plus 2 times 0 equals 8. The y term is gone, so 8 divided by 3 is 8/3. Again, keep in mind that that's your x-intercept, so the x value was 8/3. Your y value is going to be 0. Again, I'm just going to estimate it. 8/3 is about 2 2/3. So I'm just going to estimate about where that is. Y-intercept, putting 0 in for x.
Oh
3 times 0 plus 2y equals 8. I'm going to divide by my 2. So my y-intercept is 4. Again, I could put it in as 0, 4 with the y value being 4, or just click on the 4 on my y-axis because it's my y-intercept, and then I can click on my 2 dots and put my line in there. Seven, 8, and 9, finding the intercepts of a nonlinear function given its graph. So we're just picking out what the x-intercepts and y-intercepts are. X-intercepts, where does my graph touch the x-axis? Y-intercept, where does it touch the y-axis? So first of all, if I'm doing my x-intercepts, I touch the x-axis right there and right there. So this one would be at -3, this one would be at +1. Tells me if I have more than one answer to separate them with a comma. My y-intercept, where does my graph touch the y-axis? It touches right here between the -2 and -4, so it touches at -3. And that's the only place it touches the y-axis. So x-intercept, where do we touch the x-axis? Y-intercept, where do we touch the y-axis? So number 9, I am finding my x and my y-intercepts. So first of all, my x-intercepts. I touch my x-axis right here and right here, which would be at -2 and +4. My y-intercept, where am I touching my y-axis? Right there at 2 is the only spot that I'm touching my y-axis. So my x-intercepts were -2 and +4. My y-intercept, 2. And number 9 then. Finding my x-intercepts and my y-intercepts. So my x-intercepts, I'm touching the x-axis right here, also touching here. Right in the middle here, that's at 0, that one's at 2. My y-intercept, also touching right there. Right in the middle, the y value, 0. So my y-intercept would be 0. 10, 11, and 12, we are graphing a parabola in the form of y equals ax squared. You get what's called a parabola. It looks like a U when you graph a quadratic expression, which is one with a squared term. So whenever you have something with the second degree, the squared being the highest, you should always get a U shape. If my coefficient is positive, my U goes upwards. If it's negative, it's going to flip it upside down because it reflects it across the x-axis. I am graphing my parabola, and this parabola doesn't have any adding or subtracting. Later on, we're going to talk about horizontal and vertical shifts. This one has no shifts to it because it doesn't have any adding and subtracting. So with any of my graphs, the middle of my graph always starts off at 0, 0, unless I have a shift to my graph. So in this case, I'm going to make a table, and it's going to tell me to plot the vertex and then 2 points on each side of the vertex. My vertex is going to be when x is 0 since I have no shift. So when I graph, I'm going to do 2, 1, 0, -1, and -2. Basically, all I'm going to do is plug those 5 values in for my x, solve it, plot my 5 points. So if I do this, I'm going to have -5 times 2 squared. I have to do my exponents before I multiply, so 2 squared is 4. I'm taking -5 times 4. The 4's cancel out, so I just get the -5. Then I'm going to take -5 times 1 squared. Well, 1 squared is 1. -5 times 1, still -5. That's one of those where you have to use the plot point tool and type in the ordered pair. It looks something like this. When you click on it, it gives you the little boxes to type in your coordinates, and the computer will plot that one for you. Then I'm going to do my -5 times 0 squared. Well, 0 squared is going to be 0. And negative 5/4 times 0, still going to be 0. Next, I'm going to do negative 5/4 times negative 1 squared. Negative 1 squared. Negative 1 times negative 1 is positive 1. Negative 5/4 times 1, negative 5/4. Lastly, I'm going to do negative 5/4 times negative 2 squared. A negative 2 times a negative 2 is a positive 4. 4's are going to cancel, so I just get that negative 5 on the top. So if you did this correctly, notice the answers for 2 and negative 2 are the same, and the answers for 1 and negative 1 are the same, because I have to get my graph to look like a nice U. Plotting my points. 2 over, down 5. The next one I'm just going to estimate. So I'm going to go to 1 and negative 5/4, which is just a little bit below the negative 1. 0, 0 right in the middle. Negative 1 is at negative 5/4, and negative 2 is at negative 5. Once you put your dots on there, you're going to hit the graph button, and it's going to connect the dots. And if I could draw straight, I would have my parabola, this one being flipped upside down because my coefficient was negative. So basically, when you're graphing your parabola, you're just going to use the values 2, 1, 0, negative 1, and negative 2. Plug them in and solve, plot your 5 points. So on number 11, I'm graphing y equals 1/2 x squared. Again, there's no adding or subtracting in your problem, so you know, or hopefully should know, that 0 is going to be in the middle. I want 2 points on each side of that, and so I'm going to go 2, 1, 0, negative 1, and negative 2. Plugging that in, 1/2 times 2 squared. 2 squared is 4. Half of 4, going to be 2. 1/2 times 1 squared. 1 squared stays 1. 1/2 times 1, still a half. 1/2 times 0 squared. 0 squared is 0, and anything times 0, still 0. 1/2 times my negative 1 squared. When I square a negative 1, it becomes positive 1. So 1/2 times 1 is 1/2. And then 1/2 times negative 2 squared. When I square a negative 2 times negative 2, it becomes positive 4. Half of 4 is 2. So those answers match up, those ones match up, 0's in the middle, and I'm going to plot my points. So 2 over up 2, 1 over is up a half, 0, 0, negative 1 is up to 1/2, negative 2 is up to 2, and then you're going to hit the graph button, which is then going to make your parabola. This one's going upwards because my coefficient was a positive 1/2. So number 12, same kind of thing, I'm graphing my parabola. I know hopefully by now that in my table I'm going to use 2, 1, 0, negative 1, and negative 2. So negative 3/2 times 2 squared. Now if you're really bad with fractions, you could just put it into your calculator just like that. It should give you the correct answer. 2 squared is 4. 2 goes into 2 times. 2 times my negative 3 should be negative 6. Negative 3/2 times 1 squared. 1 squared still is 1. A negative 3/2 times a positive 1 is negative 3/2. Negative 3/2 times 0 squared. 0 squared is 0. Anything times 0 is still 0. So negative 3/2 times 0 is 0. Negative 3/2 times my negative 1 squared. When I square a negative, it becomes positive. So negative 1 times negative 1 is a positive 1. I'm then going to take my negative 3/2 times my positive 1, which is negative 3/2. Negative 3/2 times negative 2 squared. Negative 2 squared, negative 2 times negative 2 is a positive 4. 2 goes into 4 2 times. 2 times my negative 3 should give me negative 6. So I have 2 negative 6, 1 negative 3/2, which would be negative 1.5, 0, 0, negative 1 and negative 3/2, and negative 2, negative 6. And again, I'm just going to hit the graph button, which is going to connect my dots and make my parabola for me. If you hit graph and it's not looking like that U shape, something's wrong on your table. (13, 14, and 15), now we are graphing a cubic function. So something like 1/2 x cubed. Same kind of thing as when you did your parabola with your squared function. There's no adding or subtracting, so the middle of your graph is going to be right at 0. So when you make your table, you're going to use the same numbers we did when we did the previous problem, because we know the middle's at 0, so we're going to use 2, 1, negative 1, and negative 2. And basically, we're just going to plug them in and find our points. So 1/2 times 2 cubed. Following my order of operations, I have to do my exponent first. 2 to the third. 2 times 2 times 2 is 8. 1/2 times 8, half of 8, 4. 1/2 times 1 cubed. 1 to any power always stays 1. So 1 to the third power is 1. 1/2 times 1 is still 1/2. 1/2 times 0 to the third. 0 to any power always stays 0. 0 times 0 times 0 is 0. When I take 1/2 of 0, I still get 0. Anything times 0 is 0. 1/2 times negative 1 cubed. Here, when you have negative 1 cubed, negative 1 times negative 1 times negative 1, it's going to stay negative since you had an odd number there. So 1/2 times negative 1 is negative 1/2. 1/2 times negative 2 cubed. Same kind of thing there. When I cube my negative 2, negative 2 times negative 2 times negative 2, it's going to stay negative. So I'm going to get a negative 8. So 1/2 times negative 8 is going to be negative 4. Positive times a negative is a negative. So notice on your cubic function, these answers are opposites, these answers are opposites, and of course the 0 is in the middle. Well, what does that look like? Well, we'll plot our points. So 2 over up 4, 0 over up 1/2, 0, 0 in the middle. Negative 1 is down to negative 1/2. Negative 2 is down to negative 4. So in this case, my cubic function will end up looking something like that. Again, you'll just hit the graph button. It'll connect your dots for you and make your graph of your cubic function. Number 14 then, same kind of thing. I have no adding or subtracting, so I know 0 is going to be the center of my graph. So 2, 1, 0, negative 1, and negative 2 are the 5 values I'm going to use to plot my points. So negative 11/8 times 2 cubed. 2 to the third power is 8. The 8s are going to cancel out, so I just get the negative 11. Again, if you're really bad with fractions, put it in your calculator. Negative 11/8 times 1 cubed. 1 to any power stays 1. So negative 11/8 times 1 is negative 11/8, and of course that one's 1 you have to use your plot point tool on. Negative 11/8 times 0 cubed. 0 cubed is 0. Negative 11/8 times 0, still 0. Negative 11/8 times negative 1 cubed. Negative 1 cubed, stays -1. A negative 11/8 times a -1 changes that to a positive 11/8. Negative 11/8 times -2 cubed. -2 cubed is -8. Here the 8's cancel out, but the negative does not. That's a -1. So a negative times a negative is going to give you a positive 11. So again, these answers should be opposites. Those answers should be opposites. The zero's in the middle. So 2 -11. 1 is at -11/8, which is just a little lower than -1. 0, 0. -1 is at a positive 11/8, and -2 is at a positive 11. So this time my cubic function looks something sort of like that. So your cubic function, if it's positive, will come from the bottom, have a little curve and go up. If it's negative, it's going to come from the top, have a little curve and go down. And number 15, same kind of thing. I'm graphing my cubic function. Has no adding or subtracting. So hopefully by now I know I'm going to use 2, 1, 0, -1, and -2. So -3/4 times 2 cubed. 2 cubed is 8. 4 goes into 8 2 times. 2 times -3 is -6. -3/4 times 1 cubed. 1 to the 3rd power stays 1. -3/4 times 1, -3/4. -3/4 times 0 cubed. Hopefully by now you know that's 0. 0 cubed is 0. -3/4 times 0 is still 0. Anything times 0 is 0. -3/4 times -1 cubed. When I cube my -1, it is still going to be -1. -3/4 times -1 makes that a positive 3/4. And -3/4 times -2 cubed. A -2 cubed is -8. 4 goes in there 2 times, but I still have that negative sign. So I have a -3 times a -2. -3 times -2 is positive 6. So again, these are opposites. Those are opposites. The 0 is in the middle. So 2 -6. 1 is at -3/4. 0, 0. -1 is at positive 3/4. And -2 is at positive 6. So I'm going to come from the top, have my little curve, shoot down to the bottom, and there's the graph of my cubic function.